Alright guys, let's do this again. Started off pretty rough in block 1 today. Messed up quite a bit the first 20-30 minutes of class. Had to kind of start over. I just recorded 4 sections of this video and accidentally deleted them and can't recover them, so we're doing this over again. What you have on your screen right now is the special trigonometric angles you're really going to need for topic 8.5. So I'll also help you right now, once we start calculating these, determine whether or not you're doing the right calculations, or you can quickly convert them to decimal to check your work. So go ahead and copy these down. This would have been your bell work today while I took attendance and everything. From there, we're going to learn the 3 trigonometric ratios we're learning in this class. After that, we're going to learn the arc, cosine, arc, sine, arc, tangent. That will take us from the side lengths to an angle measure. We'll prove that this works by finding the other 2 angles in a right triangle and showing that it adds up to 180, so that these are in fact the correct way to do all of this. Then we're going to do a word problem with a plane. I'm going to ask that you, to show me you watched this video today, especially block 6, 7, and 8, turn in participation where you find the shortest path that you can fly with. I want you within 5 feet of the mountaintop on that problem. Just show me that you tried at least 5 different angles of elevation where the plane does not crash into the mountain, but it does not clear it by a considerable amount. I will solve it for the first angle, the 12 degrees that I give you, and then you're going to slowly decrease it until you find an angle that brings you extremely close to the top of that mountain without hitting it. Alright, so now we have our trigonometric ratios. We have sine, cosine, and tangent. On this screen, I'm going to use my mouse pointer to kind of show you how we set all this up. On the next screen, we're going to actually use the pen to show you for a single angle, the sine of that angle, the cosine of that angle, and the tangent of that angle. So, the trigonometric ratios, or functions, relate the side lengths of a right triangle to its acute angles. All right triangles have 2 acute angles and a right angle. That's all that's saying. B and A are our acute angles. C is our right angle. Now, before I jump into sine, I want to remind you again that the right angle symbol will always point at the hypotenuse. We're going to have to identify the hypotenuse, the opposite side from an angle, and the adjacent side to an angle. Right now, while we're learning this, while we're still getting used to it, always identify the hypotenuse first. Then, depending on the angle you want, here we want the sine of A. Start at A and always draw a line straight across, just like that, to the opposite side, and that will give you the opposite and the adjacent. Now if I did B, if I went straight across from B, this would be the opposite and this would be the adjacent to B, but we'll worry more about that on the next slide. My point is, the opposite and the adjacent for each angle that we look at will be different depending on which angle we start with. The other way to tell is for A, we have the vertex, the point where the 2 rays originate, and from those we have this black line and this blue line, and the side that those create, that third side that they create, will always be the side opposite of A. So if you follow the lines outwards, when they intersect with that other line, that will be the side opposite of the angle. Same here. Here's B. The black line goes this way. Sorry, the black ray. I'm just going to say gray. I don't know if it's orange or yellow right now. I want to say more of an orange. But this ray and this ray meet at this blue line, so that is the side opposite of B. I can also take my mouse and go straight across and see that that's the side opposite. Really, right now we're just going to keep working on opposite, opposite, adjacent until we get this down. So for sine of A, I'm going to start at A, and I want the length of the leg opposite of angle A, so I'm going to go straight across, and then I want the hypotenuse, so it's going to be that leg divided by the hypotenuse. Excuse me. For cosine of A, I'm going straight across. I see that that's the side opposite, but I don't want opposite. I want adjacent and hypotenuse. Once I know this is opposite, that means the other 2 have to be either the hypotenuse or the adjacent side. And that's a quicker way to learn adjacent. Once you get used to this, you're going to be able to find adjacent quickly. It'll make a lot more sense. But for now, if you want to rule it out and make sure, I always go with the opposite side. It's so easy. to just go straight across the triangle and find the opposite. And then if I need the adjacent, it's the third leg that's not the hypotenuse. So we're going to do the adjacent side divided by the hypotenuse. And the tangent is a little different. It's the only one that doesn't take into consideration the hypotenuse when we find the ratio. So we're going to do, looking at A, we're going to put the side opposite over the side adjacent. So here, straight across, that's going to be our numerator. And then the side that's adjacent to A will be our denominator. Alright, so let's actually use these trigonometric ratios so we can see how they work. Here I have the triangle HGF. No, come on, accept it. So HGF, and we have our hypotenuse length of 15. Right here, my right angle points right at it, so this is going to be my hypotenuse. Now, I can go ahead and label that because the hypotenuse will always be the hypotenuse. It doesn't matter if I'm doing this from respect to F or H or G. The hypotenuse is always across from the right angle. That right angle corner always points right at the hypotenuse. So I can go ahead and label that one right away every time. Now, I'm looking at this from regards to H, and it wants the sine first. So recall that the sine of H is equal to the opposite side over the hypotenuse. So going back to H, it's a little harder to draw with this than it looks. I go straight across, and I'm going to hit the side GF, and the length of GF is 12. So my opposite side is 12, and my hypotenuse is still 15. So sine of H is equal to 12 over 15. Cosine of H is going to be the adjacent over the hypotenuse. Now, if you're in class today, you can look at the board on the left. You're going to want to definitely include all of that information in your notes. Now, from H, we've already determined that 12 is opposite. I can do it two ways. I can follow this line, or this ray, and this ray, and see that they both will intersect with GF, or straight across is 12. So this is going to be my opposite. Let's put it in black. Now, if this is my opposite side from H, and this is my hypotenuse, this must be the adjacent side, just by process of elimination. And that's why I said find the opposite first every time. It helps everything kind of just fall into place. Now for cosine, I want the adjacent side over the hypotenuse. So that's going to give me, 9 over 15. So I can write cosine of H is equal to 9 over 15. And then we have our oddball, which is tangent. I call it the oddball only because it's the only one of these functions that does not require us to look at the hypotenuse. This is always going to be the opposite side over the adjacent side. Now we're still looking at H, and we've already labeled it all, so all we have to do is say our opposite side is still 12, and our adjacent side is 9. All we have to do to set these up, we're not calculating them yet, we're getting to that point, but we're not quite there yet. As long as you can set these up, you're good to go. Now, I will do one other one, just so you can see that from a different angle, these values will change. This will no longer be opposite, this will no, well, this will always be the hypotenuse, sorry, but this will no longer be the adjacent side. So let's pick angle F, and we're going to do the cosine of F. Now from F, I go straight across F, and now it's no longer the adjacent, it's the opposite. And from F, this is still the hypotenuse, so then this is no longer the opposite. This, by process of elimination, is the adjacent. So now I want adjacent over hypotenuse. Excuse me. Now, my adjacent is 12, and my hypotenuse is 15. Now we have cosine of f is equal to 12 over 15. Let's look at this word problem. We have a plane that takes off and climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088 foot mountain that is 12.5 miles from the runway, or does the plane need to increase its angle of ascent? So I'm going to copy over this triangle into our actual drawing area. We're going to switch over there, and we're going to start constructing this so we can look at it and see. So we have a plane that would take off and climb at a 12-degree angle. So realistically, let's go back to black. The plane should be taking off from here, and it's slowly going to climb at a constant 12-degree angle. So that's right here. This is our 12-degree angle. Now, we want to know, is it sufficient to fly over a mountain that is 11,088 feet? Oh, we're not going to have enough room here. 11,088 feet. If it has 12.5 miles from the runway. So that means from the point it takes off, as it goes on this horizontal line, it has 12.5 miles to gain enough elevation to make it over these mountains at 11,088 feet. So the first thing we have to do is make sure we're working in the same units. Let me find this real quick. Please disregard the kids at the basketball court while I'm over here at my dad's house. Now, from 11,088 feet to 12.5 miles, we want to know which one do we want to work in. Well, I know there's 5,280 feet in a mile. So if I have to do 5,280 times 12, I'm going to be in 60,000 feet and 11,000 feet. Those are just such large numbers. I don't really want to deal with them. Plus, once you travel 12.5 miles, it doesn't make too much sense to work in feet anymore. So I'm going to take 11,088 and divide it by 5,280. That's going to give me 2.1 miles. So I can come in here and replace this part. Oh, I just cut the triangle's edge off. With 2.1 miles. So we're at least in the same units now. So is 12 degrees sufficient to get over the 2.1 miles if we have 12.5 miles? Now, our target is not 2.1 miles. Our target is to be above 2.1 miles. So I'm going to actually make this X just to see where we would be at this angle of elevation over 12.5 miles. Oh, geez. So if I'm looking at this, I have my angle here, and I have the side that's opposite of it, and I do not have the hypotenuse, but I do have that the adjacent side is 12.5. So I know I'm going to want to use tangent. Now here we have the tangent of A. Let's not even do that. We already know that capital letters denote an angle while lowercase letters denote a side length. So when we did this before, we had tangent of A, tangent of B, tangent of E. So we're going to use an angle measure here. So that's going to be the tangent of 12 is equal to the opposite, which is our unknown, because that's what we're trying to get over. We want to know how high are we going to be over the distance that we're running or our adjacent side. Now we're going to do a little bit of algebra here, and we want to get this 12.5 out from underneath this X, so that we have X, we're solving for X. So I'm going to multiply both sides by 12.5. So I'm going to end up, when I distribute this in, I'm going to have 12.5 tan 12 is equal to, and I'm going to put it in here, 12.5x divided by 12.5 will just be x. So I'm going to plug this into my calculator. Now, I'm going to use my computer's calculator because it's going to be a lot like the one you're going to have on your test. It's going to be a lot like the one you have on your EOC. And that's just in the order I'm going to input everything in. So I'm going to put this in first. So you're just going to see I'm just going to type 12. Then I'm going to hit the tan button second. Or tangent button. I did say not to say tan or sin or cos. So I'm going to hit tangent. And I'm going to get 0.212556516.7. I think that's where your calculator stops in class. Now that's just the tangent of a 12-degree angle. I'm going to multiply that by 12.5. And I'm going to get 2.659570. Now, in this class and for this demonstration, I'm going to ask you to round to the nearest hundredths. So here's our hundredth. That's going to go up. So we're going to be at 2.66 miles. Is 2.66 greater than 2.1? Of course it is. Are we safe? We're perfectly safe. Now comes kind of the fun part. It's funner to do it in class if we could all be together and we have a race to see who can get within 5 feet of the top of the mountain first by adjusting, and I do the numbers to see how close you are, and the first pod to get within 5 feet wins. But what we can do to play with that is take exactly this equation, 12.5 times the tangent of, and this is where you play with your angle of elevation. You're not going to use 12. We're at 2.6 miles. We're half a mile. We're more than half a mile above clearing that mountain. So what we're going to want to do is keep decreasing this angle. So we're going to want to pick an angle that is less than 12 and see if we can get really close to the mountain. So I'm going to pick an angle just to start so you can kind of see what I'm doing. I'm going to say 12.5 times the tangent of 11.2. And we're going to see how close are we to this mountain. So let's put it into the calculator. Remember, you put the angle measure in first. So 11.2. Then I'm going to hit the tangent button. And I'm going to do times the runway length of 12.5. And I'm already down to 2.47. And that's still greater than 2.1, so I'm safe. But I'm still a third of a mile and more than a third of a mile above that mountain. So the second thing I want on your participation sheet today is, what number did you come up with that's still greater than 2.1 that gets you extremely close to the mountain? I'm looking forward to seeing them today in block 4. Was it block 4? Yeah, block 4 got within 2.9 feet of the top of the mountain. That was pretty impressive, and it didn't take us long. I think we only tried 7 or 8, but they were very quick to see what adjustments they needed to make. Alright guys, let's start working on finding the angle when we know the side lengths. Now, the calculator built into my computer won't do these symbols here. So I'm going to talk you through how to find it before we even start. On your calculator, the one that you can use on the EOC or on my test in class, you know where the tangent, the cosine, and the sine button are. They're right there by the off switch. Now, if you look above them, but not the next button above them, but that little printed piece on the calculator, you'll see Arcsine, which is what we call, what I've underlined here. This is arc cosine, and this is arc tangent. What I'm saying is arc sine, arc cosine, and arc tangent. And they look like these right here on the calculator. We're kind of at a shift where a lot of my professors said this is how they were raised on the Arcsine notation, and this is how I'll say our generation, even though I had a class think I was 57 years old, but the next generation of mathematicians are coming up with this being the standard notation. So these mean the same thing. You pronounce it arcsine, arc cosine, and arc tangent. So you're going to see those little buttons up there, and to use them or to access them, you're going to hit the second button, which is the top left button on your calculator, and then it'll function just like that for you as it would if we were just trying to find the sine. Got a little mess over there too. Now, what it wants to know is it wants us to find the measure of angle B. So I'm going to look at angle B here, and I'm going to look at the information that I have available. Right now, I have the side that is opposite B, and I have the hypotenuse. So, right away, seeing opposite of B and the hypotenuse, my mind goes straight to the arcsine of B. Arcsine finds the angle measure. So anytime I ask you to find an angle measure, you're going to use arcsine. When it's looking you for lengths of sides or measures, you're going to use regular sine. So arcsine of B will give me the angle measure, and that's going to be 1/4. Now this is the part that's going to, here's the first major error. This is the number one, I call it thimble mistake. I remember taking this in school and doing this over and over and over again. On your calculator, you want to do 1 divided by 4 and then hit equals before you do that. You have to get it as, thank you. You have to get it in, you have to do the 1 divided by 4 before you hit sine. If you do not hit equals, you do 1 divided by 4 equals. If you do not hit equals and then you do arcsine, you're going to find the arcsine of just that 4. But what we really need is the arcsine of 1/4. So 1/4 equals, before you hit arcsine, you should have 0.25 in your display. Second, and then sine. And that will give you 14. So right now, we're going to see on our calculator, the measure of angle B is equal to 14.47751219. That means the measure of angle B, and we're still rounding to the hundredths place. That was my brother, guys. I'm sorry. We're all kind of over here trying to figure out what we're going to do with my kids tomorrow. And of course, he probably finds that very funny, and I apologize. Measure of angle B, rounded up, is 14.48 degrees. Now, how do we know that's right? Well, the best way I know is to find out if the sum of angle B, angle C, and angle A is 180 degrees. So now I'm going to add on to this slide by asking you to find the measure of angle A. Now, from A, going straight across, is this side. Now, I can do the math and find out that this is the square root of 15 and do sine 15, square root of 15 over 1. But let's make it a little bit different. If this is the opposite side, let's not worry about this. This is the opposite side. What do I have? I have the side adjacent to A, and I have the hypotenuse again. So adjacent and hypotenuse is cosine of A, arc cosine of A, because I'm trying to find the measure of angle A. And that's going to be equal to 1/4. Adjacent over hypotenuse. Cosine inverse, or arc cosine of A is equal to 1/4. So again, on our calculator, 1 divided by 4 equals, make sure you're displaying 0.25 before you move on. So, now I'm talking and punching the buttons. All right, 1 divided by 4 equals, I'm now showing 0.25. Now I'm going to hit second cosine, and I'm going to get that this is equal to 75.522. So I can round this down to be exactly 75.52. So going back, my measure of angle, let's do it on a, ooh, I don't want to do a new screen. I'm just going to cut my answer here. So the picture I saved, I had measure of angle A, the measure of angle B, and the measure of angle C. Let's pull that back up. Move it over here. Alright, I said the measure of angle A, because I found the cosine of A at 1, the arc cosine of angle A at 1/4. See, this is starting to turn into block 1 all over again. Is 75.52. The measure of angle B was 14.48, and the measure of angle C was 90. So if I were to add that up, I would have 90.00. This is going to be 8 plus 2 is 10, carry the 1. 5 plus 4 is 9, plus 1 is 10, carry the 1. 5 and 4 is 9, plus 1, carry the 1. 1 plus 7 plus 1 is 9, plus 9 is 18. So I have 180 degrees. So yeah, this is definitely a triangle. It's definitely a right triangle. And these angle measures check out and they make perfect sense.